Alright, here we go, gang. Transition metal ionic bonding naming. So this works just like binary ionic naming, only with a caveat, because we're going to be using transition metals. Remember when we had our periodic table, we talked about how, this is my awesome periodic table. We talked about how this column always makes a 1 plus, this always makes a 2 plus, and then you have 3 plus, and then 4 minus, 3 minus, 2 minus, 1 minus, and I've run out of room. But anyway, and then we always skipped over the transition metals, this group right here. And that's because these guys can form a variety of cations. They always make cations because they're metals, but they can have charges that range anywhere from +1 to +5, just kind of depending on how they feel. Some of them are always very specifically what they are, but for the most part, a lot of them can change. So here's our rules for naming with transition metals. Okay, they're named with a Roman numeral to indicate the charge. Right? So if we're going to name chromium, it's one of our transition metals here. We're just going to name it just like normal. It's just called chromium ion. But instead, we're going to tell us what the charge is using a Roman numeral. So you're going to put parentheses, and because the charge is 2, you're going to use Roman numeral 2. And then chromium 3 plus, you say chromium, and then 1, 2, 3, like so. So you got a chromium 2 ion and a chromium 3 ion. One is 2 plus, one is 3 plus. There's a couple of exceptions, okay? Almost always, right? So silver, cadmium, and zinc are really nice in that they almost always make the same charge. Okay, this is how I remember those. So if this is the corner of the periodic table right here, where it starts the transition metals, so like aluminum is right here, and we know aluminum makes a 3 plus, and this is boron, right? Aluminum, boron. Okay, you put your zinc right here, and it only makes a 2 plus ion charge. And then we have cadmium right underneath it, and it makes a 2 plus charge, and silver is right next to that. So you almost get like almost the stair step effect right here. That makes like you get your 3 plus, then your 2 pluses here, and then your 1 plus. That's how I'd memorize that. Okay, and then also the other exception is lead and tin sit down here in the non-metal section, but they're underneath the yellow staircase of the metalloids. Okay, so they sit under here, and they also need Roman numerals, because lead can have it can be like 3 plus, 2 plus, or 1 plus, and tin can be like 2 plus or 1 plus. So they're kind of funny that they act like transition metals because they're so far down the periodic table. Alright, so we're going to write some formulas. You've got copper and chlorine. Notice how, because it's transition metal, I had to tell you what the charge is. Okay, so copper in this case has a charge of 2 plus. Our chlorine is just a halogen, just like it's always been. It's a -1 charge because it's group 7A. And so we need 2 chlorines to balance out the 1 copper. Okay, so we'll say CuCl2. Right. You can also do the crisscross method. Bring the 2 down to the chlorine and the 1 down to the copper. You get the same thing. Nickel oxygen and nickel oxide. You get 6A. This makes it a 2 minus charge. Okay, you can do the crisscross, so you'd get Ni2O4. Right? But notice we can divide both of them by 2, so it'd just be NiO2. You could also notice that we need 2 of the oxygens to balance out the charge of the nickel. The nickel's 4 plus, and the oxygen is 2 minus, so you get NiO2. Now, when you're naming these, it's going to be about the same as you're used to from binary, only we have to use those Roman numeral things. Okay, so this is going to still be magnesium chloride, but we have to come up with the charge of that manganese. Well, we know that chlorine, since we have 2 chlorines, we have 2 negative 1s. Okay, now, so that gives us a -2 overall. We need to figure out how many manganese we need to get a +1. Well, we know there's only one of these guys, so there has to be only 1 manganese, so its charge has to be 2. Okay. You can also think about doing an opposite crisscross, but it doesn't always work. If you bring this 2 up here, it shows you that the manganese is 2 plus and this is minus 1. Okay, now the iron 2 oxide here, iron 3 oxide, we've got iron, okay, and we're going to have some Roman numeral in the middle, and then oxide, and we have to figure out what that Roman numeral is going to be. Now the oxygen, we know for every oxygen, it has a charge of 2 minus. Okay, so that means overall, we have a 6 minus charge. Okay, now we know that between our 2 irons, we have to come up with 6 plus. So 6 divided by 2, and we know that iron has to have a charge of 3 plus. Okay, now we can double check ourselves by seeing if that works. We could say, okay, we have Fe3 plus and O2 minus. Will I get Fe2O3? All right. Well, you could do the crisscross, where you get, and you'll end up with Fe2O3. All right. Now we have iron oxide here. Okay. Well, you know oxygen has a charge of 2 minus. Okay. So this gives us a 2 minus. But iron here, we only have one of them this time, and we know that one of these has to give us a charge of 2 minus, so therefore it has to have a charge of 2 plus. So this iron is going to be 2. Now we're going to write the formula. So the first step to write the formula is just like normal. You're just going to figure out what your charges are. So this is cobalt 3 plus, and we know it's 3 because it gives us a Roman numeral 3 right there. The nitride is N3 minus because it's in that group of 5A. Right, so 3 minus, 3 plus. We can crisscross them, or you can notice that if we have one of each of them, they'll equal 0. So this would simply be CON, cobalt nitride. Now we have lead 4 chloride. Well, this is Pb 4 plus and Cl minus. The lead we know is 4 plus because we've got the Roman numeral there telling us so, and then we've got the chloride is in the 7th group and it has a charge of -1. We can do the crisscross method, or we can see that we need 4 chlorines to match up our lead, so this becomes PbCl4. And that's it for naming transition metal ionic compounds. Do some practice, check your work, and come do your checkpoint.